Hi everyone, welcome to our 8.1 online lesson. We're looking today at graphing systems. So a system is two lines graphed on the same graph, and we're going to be looking at how to solve a system or how to look for the point of intersection. So we're in our 8.1 notes and we are going to go ahead and get started. So first of all, what is a system? Up until now, we've been looking at graphs of linear equations, so straight lines that I can graph on a piece of graph paper. Now I'm looking at something a little different called a system. And a system is whenever we have two or more lines on the same graph. So two or more linear equations is called a system. Okay, so for example, a system is the line y equals negative x plus 2. All right, there's one line or one linear equation that represents a line, and another line, y equals 3x minus 2, call that line 2, graphed on the same grid. Okay, that's a system. So a system can be graphed. If I went ahead and graphed y is equal to negative x plus 2 and y is equal to 3x minus 2, I see that the red line has a negative slope and the blue line has a positive slope, and it turns out that because they have different slopes, they cross at a certain point. The point at which these two lines cross is called the solution. So the point where the lines intersect, the point of intersection, is called the solution. Okay, so the solution to the system of two lines. What that means is that there's only one point on this graph, okay, and in this case it's this point right here, which is the point, let's have a look, x equals 1 and y equals 1, if I look at the coordinates of that point. So these lines cross at the point 1, 1, x equals 1, y equals 1, which means that that's the only point that is going to satisfy my red line and satisfy my blue line, or in other words, that's the only point that these two lines share. Okay, let's write that down. So this is the only point that both lines, or in other words, both linear equations, share. So this point satisfies, so the point 1, 1, 1, satisfies both equations. Okay, it's the only point that they're going to share. That's why we call it the solution. We could go ahead and graph, if we're given two linear equations, we could graph them, and to solve them then we're just going to be looking for the point where they cross. So let's go ahead and carry on. So when you find the point of intersection, just to define some language here, when you find the point where two lines cross, you have found the solution. In other words, you have solved the linear system. Okay, so don't get thrown off by a question that asks you to solve a system. It just means literally solving, okay, means find the point of intersection. So how are we going to do that? Today we're going to graph it and we're going to figure out where they cross. What is that point? Okay, that is the solution. Sometimes you don't have to graph it. If you're given a table of values, you can actually find the point that they both share just by looking at the table of values. So for example, on a graph, it's easy, okay? We look for the point where the lines intersect. But if we were given two tables of values, okay, we could look, so these, let's say that this would be for line 1 or equation 1. And over here, we have a table of values that represents line 2. And maybe you came up with the table of values yourself if you were given the equation, or you were just given two tables of values. you're looking for a point that they both share. So you're looking for some point, the solution, okay, it will be the point of intersection, but it will be the point, okay, that both lines share. So we're looking for some point, x, y, that they both have, okay, in their table. So for example, if we look at the first point in the first table is 0, 0, and in the second table it's 0, 2. So I can see right away that the first point in both tables is not the solution because x and y are not the same. But if we look a little bit lower, we see right here that the point 2, 4 in my first table and the point 2, 4 in my second table share the same x value and the same y value. And if you look at all the other points in both tables, none of the other points have matching x and y values. So I can see here that the solution is, well, I see that x equals 2 and y equals 4, which means that is the point. If I wrote those coordinates as a point, x comes first, so 2, and then y comes next, that's the point 2, 4. So without even having to graph this one, if I'm given tables of values, I can immediately just simply highlight or see that the point that they both share will be the solution. Okay? And you could do this if you're given two equations. You could come up with two tables of values, and that's one way to solve for the solution. The other way you can solve for a solution is to graph it. Okay, and we're going to go ahead and have a look at graphing in just a moment. Before we get there, verifying a solution is an important part of solving. So if you get your answer, so for example, in the last question, if I figured out that this was my solution, if I knew the equation of both of these lines, it would be a good idea just to plug my solution in to both equations and make sure that that point actually does satisfy both of my lines or both of my equations. This is called verifying. So to verify a solution, it means to check that the solution, whatever that point is, x, y, okay, satisfies both equations. So we can verify by substituting our point, so the x and the y value, okay, into each linear equation. And what we would like to see is that, okay, the answer that we get must be valid. In other words, we must get a true statement. So let's go ahead and do this so that you can see what I mean. Okay, so if, for example, I have a system and line 1 has the equation y equals negative x plus 2, and line 2 has the equation y equals 3x minus 2. Let's say I went ahead and I graphed that, and I found that the solution was the point 1, 1. Okay, there's my solution. I'm going to verify by, I want to plug this point 1, 1 into the equation for line 1, and I want to make sure that I get a true statement. Then I'm going to plug it into line 2, and I'm going to make sure that we get a valid or true statement. Okay, so to verify, I'm going to plug in the point 1, 1, because that's my solution. So that's when x equals 1 and y equals 1. Okay, into both linear equations. In other words, I'm just going to check this point out in both of my lines. So let's check line 1. Okay, well, here's the equation for line 1. Y equals negative x plus 2. So what I'm going to do is I'm going to go ahead and I'm going to substitute in my y value and my x value with my point and just make sure that I get a true statement. Okay, so I'm going to plug in x equals 1 and y equals 1 from my point. Okay, 1, 1. Let's go ahead and do that. So we'll get a 1 for y, and that's equal to negative x, but I'm going to plug in my value of x from my point, which is 1. And the rest of the equation stays the same. Okay. So what I have now, if I simplify the math, I have 1 is equal to negative 1 plus 2. Let's simplify the right-hand side. Negative 1 plus 2 is equal to positive 1. Okay, this is a true statement. In other words, this is a valid solution. So 1, 1 is a valid solution to my first line, or to equation 1. I'm just going to do the exact same thing for line 2. So let's check line 2. Okay, we're going to verify line 2. Again, we use the equation for line 2, which is y is equal to 3x minus 2. Okay, and I'm going to plug in my solution, the point 1, 1. X equals 1, y equals 1. So I put a 1 everywhere I see a y, and I substitute in a 1 everywhere I see an x. Okay, and now I'm going to go ahead and simplify this. So let's, on the left-hand side I have 1. On the right-hand side I have 3 times 1, which is 3, minus 2. And I can go a step further. On the right-hand side, 3 minus 2 is 1. So 1 is equal to 1. As long as it's a true statement, it's valid. Okay, so 1 is equal to 1. That's true. So this is a valid solution. Okay, it doesn't matter if it's a coincidence here that 1 is equal to 1 for line 2 and 1 is equal to 1 for line 1. I could have found that 6 equals 6 when I did my check, and that, as long as it's a true statement for both lines, then it's correct. Okay, it's a valid solution for both. So it doesn't matter if when we verify it, our final answer, the true statements don't have to be the same. They just have to both be true. Okay, so this is called verification. I'm going to just add a little note here to your notes. Okay, so just a little note. So when verifying a solution, okay, we must get 2 true statements. Okay, they don't have to match. That's the key. They just both need to be true. And that's, if that is true, then the solution, which is your point, okay, is valid, okay, for both lines. In other words, it's a valid solution for the system. So it doesn't matter if they don't have to be exactly the same statement, 1 equals 1, that's just a coincidence, but they both have to be true statements. Okay, I'm going to go ahead and pause our lesson here. I'm just going to finish the last part, which is how do I graph a system and find the point of intersection. I'm going to finish that in a separate video. So I'm going to pause it right now, and I'll get you to just carry on and watch the next video with me. Thanks very much.